So, the last class we talked about various examples where there is actually relationship among variables, right. So, now the question there are a couple of questions one could think of, and here are the following. These are physiological variables. Do they vary jointly or separately? What does it mean? Suppose a person with high cholesterol, does he tend to have high blood pressure? So, that means they are varying jointly, right. There are relationships, okay, among these variables, that is what we saw. If there are relationships, can we deal with them individually, right? That is a question. If there are relationships, can we model each of them separately? Well, that will not be easier to do, right. That is only when the relationships are weaker, then we can think about, okay. So, finally, we are going to ask a question. So, if that is the case, how do I do such joint variabilities? How do I represent such joint variabilities? Okay. Theoretically as well as statistically, that is probability wise and statistics wise, right. Remember, we always start with probability theory and then move on to statistics. So, we will first define for two random variables doing jointly, okay. We will not worry about multiple random variables immediately, we will worry about two random variables varying jointly. So, it is called as bivariate distribution, probability distribution, or joint probability distribution of two random variables. So, what do I mean by joint? What do I mean by joint? So, if you want to look at it graphically, this is what I am talking about. So, this is a joint PMF, probability mass function, for a discrete variable. So, x, y and the values. So, now it has actually become 3 dimensional, x axis, y axis and the probability values. Now, looking at this graph, can you tell whether x and y are related or independent? Whether the random variables x and y are related or independent? What is the shape of the PMF? Huh? Is it looking like a triangle somewhere? Right. So, now that means what? The farther x values, the lesser the y probabilities, it is like a triangle. So, that means they should be actually inversely related, okay. When can you say that there is no relation? Looking at the shape, what shape you can say that it is no relation? What kind of shape? You understand what I mean? When x increases, y decreases and vice versa. So, that is why I am saying there is inverse kind of relationship. What kind of shape of the PDF can you assume that there is no relationship? Rectangular, right. X and y independently, they do not carry each other, most likely it should be a rectangular or square distribution, right. That is when you say there is no relationship. Here it will be clearly related. So, this is what I am talking about. Now, when I talk about two random variables, both x and y are related and we are talking about the joint occurrence. So, at x equal to 0, y equal to 4, what is the probability? We are not asking a question independently, okay. It is joint, x equal to 0, y equal to 4, it is the probability. So, the probability of occurrence of x equal to 0 is 1.6 and the probability of occurrence of y equal to 4 is 4 point. So, it is a joint. So, you have to look at it in a joint fashion, you understand. So, you can think of marginal distribution, that is for each value of x you can go along y and for each value of y you can go along x, you understand. So, from the 2 dimensional distribution, that is 3 dimensional, basically 2 x y with values, you can go along x axis or look only along y axis, you understand. So, basically this probability distribution has certain rules to it, okay. So, now the way we represent it is f of x comma y, the capital F is usually the cumulative distribution and the small f is the probability distribution function PDF. Okay. And as I said, the marginal cumulative distribution is what? F of x is for all y. You summate along y, you get f of x. You summate along x, you get f of y. So let us solve a problem and then we will get it better. So can you, this is my joint PMF, okay, for various values of x and y. Look how the function is, it is a function of both x and y, clear. So this is how usually the joint PDF looks. So now the first question I have asked is, what is the value of k? How do I find the value of k? How do I find the value of k? What idea did I use? I have also wrote down the solution. What idea did I use? The probability of sample space should be equal to 1. What is the probability of sample space? It is summation along both x and y values. So I have summed along both x and y values. So you can see, so there will be 2x, 2 values of x, 2 values of y. So totally you will have 4. Okay, clear. So for each value of y, you will have 2 values of x. So that is way you have 4 components, and giving rise to, when you equate it to 1, you get k equals to 1 over 18. Okay. Now find the marginals of x and y. How do I do? Simple, summate along y for, keep x and summate for y. So it should be a function of x alone. So what did we do? We summate along for 2 values of y, x is kept as such. So that is marginal of x, okay, 1 over 18 into 4x plus 3, that is the distribution along x, because I have just summated along y axis. What is marginal along y? The summation along the x direction. So you keep y and substitute for x values, you get marginal of y. How do I know whether this distribution is independent or dependent? How do I know whether this distribution is independent or dependent? That is, whether x and y are independent or dependent. Probability of A intersection B equals to A into B. So you have the whole distribution, you have the marginals. So if multiplication of marginals equals to the whole, then it is a x and y are independent, otherwise x and y are not independent. These are the important, the marginals, how the distribution looks like, and how do you compute independence. But remember, probability distribution computing is a theory, okay. I do not want to delve into more on this, okay. So what might be important here is what we call it as conditional distributions. Have you learnt about conditional probabilities? We learned, right, probability of A given B. So conditional distributions become very important. Any idea where conditional distribution can be important? Any idea where conditional distribution becomes important? What is the best predictor in mean squared error sense? We derived in the class. What is the best prediction in a mean squared error sense? Expectation, right, that is what we did, remember, and median was the best predictor when you use mean absolute error, right, that was actually shared with all of you. Now let us say okay, I write a model like this where y is my output, x is my input, okay. I am trying to predict y, that is why it is cap, okay, y hat, using what are the parameters? Theta hat, okay. In your simple regression this becomes y equals to mx, but theta could be a vector also, okay, and x could be a matrix also. Okay. So, the simpler case will be y equals to mx, okay, and y hat equals to m at x, right. This is what you want to actually predict. Now, what is m? What is the value of m hat? In y equals to mx, what is m hat? M hat y equals to mx, what is m? Slope. That is what we have learnt. But remember, this has to have connection with prediction, right, because you are using m to predict the value of y. So, this has to have connection with prediction. So, what could be m in terms of prediction? Slope is what you get finally, but what is in general theta hat? If I ask you theta hat, what is in general theta hat? If I want to predict and if I want to minimize the squared error, what will be theta hat? Mean of what? Mean expectation of what? Y given x. You understand? So, you are predicting y, so that means you are minimizing the square error in y. So, what is the value? Best prediction, average value of y, okay. So, we know when you predict, when you want to minimize the mean square error, what is the best prediction? It is just the average. So, what is the best prediction of y hat? Is the average of y, which is nothing but expectation of y, but what is given to you? You are not just using y alone, you are using the x values given to you. So, that is why the solution is going to be what? Expectation of y given x. In fact, this is a very powerful statement. In fact, all your machine learning techniques that you today use try to only predict, do what? Estimate expectation of y given x. All your methods today only try to estimate this quantity expectation of y given x, irrespective of whatever network you use for prediction, not classification, but for prediction. The solution is expectation of y given x, because you know mean square error, if I want to reduce, the best value is expectation. And now there is a model, and the model could be linear, non-linear, etc. So, then what am I doing? Expectation of y given x is what I am estimating. In a linear regression model, it turned out to be m hat. I wanted only a linear. If expectation of y given x could be non-linear, for example, in a neural networks. Okay. So, this is what we want to minimize, or this is what we want to estimate, not minimize, this is what we want to estimate, and that is why conditional probability distribution becomes very important. Okay. Conditional averages and conditional probability distribution becomes very important. So, I have given some examples. Okay. This is again the same idea, probability of A intersection B equals probability of A given B is what? Probability of intersection A intersection B divided by probability of whatever B, right. So, the same idea I have used here to compute expectation of x given y, but of course, none of this can be done in theory, in practice, because it requires the true probability distribution. Okay. If you know the true probability distribution, then all those expectations computations become easier, but I will never know this. Okay. So, then what can we talk about? Okay. So, then what is, so these are definitions of mean and variance. So, you should have known now you will do double integration instead of a single integration. When you want to do for x, you will do double integration, and similarly you will do double integration for variance, etc. Right. Clear? Variance of x, these are nothing but marginals. Okay. So, I have given an example, let us not worry about this. Okay.